Hi, my name is Abdul. My group will be presenting on numerical integration, and I will kick off this presentation by talking about the trapezoidal rule. I will now explain the need for numerical integration. We know that now, integrate with limits fx dx can be represented by a graph similar to this. This is the y-axis, this is the x-axis, and now let me show you the limits, where this being A and this being B. This being the area under the curve. Okay, with this area under the curve, we can actually find the trapezoidal rule. So, this portion over here, perpendicular to A and B, being called the height, h. Now, let us revise the area of a trapezium. Area of trapezium states that half of the parallel sum of the parallel lines multiplied by the distance between them will give you the area of trapezium. For example, this trapezium over here. Now, for this trapezium, these are the parallel lines, and so this is A, this is B, and this is your height. For another example, we move on to another trapezium like this. And so now, these two are parallel, and so they are A and B, whereas this one over here is the height between them, is the distance between them. Now, let me focus on how, using the trapezoidal rule, we can find an answer. This is the same trapezium. But now, the concept of trapezoidal rule is actually to divide the trapezium into smaller pieces yet equal. This being the y-axis and this the x. Now, if we take a closer look at the portion here, this is actually a trapezium where these two sides are parallel. And so, with this trapezium, we will now show you the trapezoidal rule to solve for the numerical integration. Let's say we have a term, integrate with limits root 1 minus x cubed dx. Now, using the proper integration method, we cannot integrate this because root 1 minus x cubed itself cannot be integrated. However, we can find an approximate value of the integral, and now I will show you how to do it using the trapezoidal rule.
So watch whether the something.
Now I will show you how to solve an integration question by means of trapezoidal rule. First, as usual, we have our graph with our limits A and B. This is our area under the curve. Now, let us take a very close look at this again. Now, the idea of the trapezoidal rule is actually to cut the area under the curve into smaller pieces yet equal. Now, with this, we have this area as all are different. Now, with this, we also indicate it as y0, y1, y2, y3, and y4. With that, we shall now proceed to actually see the formula to calculate this area. Now, area of this trapezium. Alright, so integrate with limits, say from here we put it 0 to 1. So integrate with limit 0 to 1, fx dx is equals to half times y0 plus y1 times height plus half times y1 plus y2 times height plus half times y2 plus y3 times height plus half y3 plus y4 times height. So this is actually, now we will take all the common factors out and factorize this equation to h over 2. I got this by multiplying half and h out, all the half and h's over here. I take out, put here, and now I'm left with y0 plus y1 plus y1 plus y2 plus y2 plus y3 plus y3 plus y4. Now, this could further be actually factorized, and I will do that by letting you direct your attention to the y's over here. Now, look carefully, there are two y1s, two y2s, two y3s, and a single y0 and y4. Therefore, we can actually further factorize this equation to h over 2, the y0 and y4 as they are alone, plus 2 times of y1 plus y2 plus y3 and plus y4. Now this over here is your trapezoidal rule. Do also note that the formula for trapezoidal rule can also be found in your formula book, page 21 of your math formula book. As I mentioned about the strips, now I will show you how to divide and get n, where n is the number of strips in the